If we're talking about linear equations, they generally come in one of three forms. First, we have slope-intercept form, y equals mx plus b. Then we have point-slope form, my personal favorite. And finally, we have ax plus by equals c, which is commonly associated with systems of equations. This episode is about the first one. For our purposes today, a linear equation, like this one, acts as a rule for the variables x and y. That means that any pairing of an x value and a y value that follow the rule marks a point on that line. The rule is determined by two other variables, m, the slope, and b, the y-intercept. Consider this linear equation. The point 14 is on the line because if you substitute the y value 4 and the x value 1 into the equation, you get a true statement. We would say the point 14 is a solution to the equation y equals 3x plus 1, because after substitution, you get a true statement. The point follows the rule. So what even is slope? Curiously, at least in the US, we assign it the letter m. One theory about why we do this is that m is the first letter in the French verb monter, which means to go up. Maybe this is a nod to René Descartes, who among his many accomplishments gave us the coordinate plane, but no one knows for sure. Anyway, the slope tells us how the graph of a linear equation goes up or down. Reading from left to right, if the slope is positive, we are going up, and if it's negative, we are going negatively up, that is, down. To see the slope in action, we can look back to this familiar equation. We see that 3 is the coefficient of x, which means that 3 is the slope. Let's plot a couple of solution points, values of x and y that give us a true statement, to see how the slope impacts the graph of our linear equation. We'll make an xy table. If we let x be equal to 1, we would say 3 times 1 plus 1 is equal to 4, so y equals 4. Doing the same thing with 2, 3, and 4 for x, we get 7, 10, and 13 for y. With those 4 solution points, we can see a clear pattern. Y increases by 3 each time x increases by 1. I wonder if we can generalize that principle. In fact, we can. For y equals mx plus b, m, the slope, can be understood to mean the amount y increases by when x increases by 1. As x increases by 1 unit at a time, the y value will increase by the slope. That's cool and all, but you may be thinking, yeah, but what if your slope is weird, like, I don't know, negative 3/4 or something? We got you covered. Let's attack your question head on. It is true that if you had a linear equation like this with a slope of negative 3/4, you could interpret that negative 3/4 slope to mean that y increases by negative 3/4 or decreases by 3/4 each time x increases by 1. I don't know about you, but I really don't want to graph a linear equation with that relationship. Negative 3/4? That's just too weird. However, if I were to reinterpret that slope, saying that negative 3/4 is the same as negative 3 divided by 4, then we could interpret the slope this way. Y increases by negative 3, or decreases by 3, each time x increases by 4. That's going to work a lot better with my coordinate plane. We can confirm this relationship is true by substituting some values in for x and seeing what I get for y strategically. If I were to substitute 0, 4, 8, and 12 in for x, values that are suspiciously spaced by 4, I would get values that are interestingly spaced by 3 and are going down, which means for every increase of 4 in my x value, my y value goes down by 3. Cool. So, for y equals mx plus b, we can understand m, the slope, to mean the amount y increases when x increases by 1, like we said before, or the ratio of the change of y to the change of x, or what your math teacher probably calls rise over run. Let's look at some examples. If we consider this linear equation right here, and we're especially fond of the rise over run idea, we can say that slope of negative 2 can be interpreted as negative 2 over 1. That means m is negative 2, which means y increases by negative 2 or decreases by 2 each time x increases by 1. Here's another example. Y equals 2/3 x plus 1. Let's use rise over run. M is 2/3. That means y increases by 2 each time x increases by 3. Enough about slope. Let's talk about the y-intercept, or the y value when x is equal to 0. If we let x be equal to 0, my first term on the right-hand side goes bye-bye, and we have the y value equal to b, the y-intercept. Well, what's so great about that? Asks our friend the cow in a top hat. To answer that question, let's say we were going to graph the function y equals negative 2x minus 3. That graph would look like this. Notice where it crosses the y-axis. That point is the y-intercept, and it happens at the point 0, negative 3. That's the same negative 3 that we see at the end of our equation. That's b, the value of the y-intercept. So the y-intercept is the point at which the linear equation crosses the y-axis, at least the y value, since x must be 0. That means the y-intercept is a really convenient point of reference when graphing. Wow, so cool. Let's put our knowledge of slope and y-intercept together. We want to graph y equals x plus 2. Since x has no visible coefficient, the coefficient is actually 1, or, because we like rise over run, let's interpret it as 1 over 1. We'll start by acknowledging our y-intercept, which is 2. So we plot the point x equals 0, because it's a y-intercept, y equals 2. Now we follow rise over run. I run 1 to the right, and I rise 1. That gets me a second point, namely the point 1, 3. Now we learn in geometry, if you haven't already, that if you have 2 points, you can draw a line, and it'll be exactly right. But just to make sure we understand the form of a line, let's plot one more point. We're going to run 1 and rise 1, and we plot our next point, namely 2, 4. Now the form of the line is crystal clear, so we can draw it using a straight edge. Again, say you wanted to graph this equation, y equals x plus 2. Well, if we want to use rise over run for our slope, we see that the coefficient of x is 1, or 1 over 1. Now we can use some rise over run. We're first going to start with our y-intercept of 2. We plot the point 0, 2, then we run 1 and rise 1, and then we have our next point, 1, 3. And for one additional point, we run 1, rise 1, and we get 2, 4. You only need 2 points to make a line, but with 3 points, it's crystal clear. Let's do one more example on our blackboard, or green board, or whatever. Y equals negative 3x plus 1. We see our slope is negative 3. To use rise over run, we can say negative 3 is negative 3 divided by 1. Now we can use rise over run. We start with our y-intercept of 1, plot the point 0, 1, and then follow a rise over run of negative 3 over 1, and that would get us 1, negative 2, and 2, negative 5. 2 points are all you need, but 3 is fine indeed. Now here are some problems for you to try. For each equation, state the slope and y-intercept, then graph. We'll start with y equals 2/5 x plus 2. Feel free to pause the video, give this one a go, and unpause the video when you want to check your answer. Okay, I'll assume we're ready to continue. The slope is 2 over 5. The y-intercept is 2. The line would look like this. All right, let's move on to number 2. Y equals negative x minus 1. See if you can identify the slope, y-intercept, and then graph. Pause the video, and then unpause when you have an answer. All right, I'll assume we're ready to continue. The correct answer is slope is negative 1, or negative 1 over 1 if you want to use rise over run. Y-intercept is negative 1, and the line looks like that. Now let's look at a couple word problems. that would require us to use a linear equation. We'll use slope-intercept form. A company rents bounce houses for a flat fee of $100 plus $50 per hour it's being rented. So we need to pay $100 regardless of how long we have the bounce house, but we need to pay $50 per hour it's being rented. Write a linear equation that gives the amount y you'd need to pay to rent the bounce house for X hours. Then find the cost of renting the bounce house for 4 hours. Pause the video and see if you can do this problem all on your own. Unpause the video when you have a solution to both parts of this problem. Okay, I'll assume we're ready to look at the answer. Y equals 50x plus 100 is the equation that gives the amount y you'd need to pay to rent the bounce house for X hours. We see that X is our number of hours. We multiply $50 by that number of hours, $50 per hour. But let's not forget that flat fee of $100, which we add on to the $50 per hour fee. That would give us y, the amount we would need to pay for the service. Now let's answer the second part. When X equals 4 hours, that is, we rent the bounce house for 4 hours, we substitute 4 in for X and get $300. So, for 4 hours, our linear equation says we would owe $300 for the bounce house. Here's another problem that uses slope-intercept form. As someone who tutors tests like the SAT and ACT, this is the kind of problem that they like to put on their tests. The equation d equals 50t plus 10 models the distance d, in miles, of the DeClerico's car from their house on their way to vacation at time t, where t is in hours after 9 a.m. What do the numbers 10 and 50 represent? Think about it, pause the video, try this problem on your own, and unpause when you have a solution. Okay, I'll assume we're ready for the answers. At 9 a.m., the car is 10 miles from home. This 10 right here is a starting point. It's our y-intercept. A y-intercept is the value of d in this case when t equals 0. When no time has passed, at 9 a.m., the car is 10 miles from our home. Now on to that 50. The car travels at 50 miles per hour. Well, how do I know that? Well, you may remember an equation, distance equals rate times time. Now, we do start 10 miles from home, but just ignore that for a moment. Distance equals rate times time. 50 is apparently a rate. We multiply it by a time, that is in hours, and we get a distance in miles. Well, what do I multiply by hours to convert to miles? I would need hours in a denominator and miles in a numerator. Miles per hour. Hope you enjoyed this set of skill drills from The Math Show with Mr. DeClerico. Be sure to subscribe, hit the like button, and all that good stuff.